All right, Algebra 2, we're going to go ahead and do Unit 8.1. So Unit 8 deals with a new function called logarithmic functions. We short it to log functions. So we're going to look at graphing log functions and solving and simplifying. So let's review this exponential function y equals 2 to the x power. And so we have this XY table all made up for us. And so we're just going to plug -2, -1, 0, 1, 2 in for x and find the y values. Okay, again, all these numbers are going in for x. So 2 to the -2 is going to be 1/4. All right, so again, that's the same as 2 to the -2, which is 1 over 2 to the +2, because you flip it, and that's 1/4. All right, 2 to the -1 is a half. You can use your calculators. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. All right, now we're going to go ahead and plot these points real quick. So -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. All right, so hopefully the shape of the exponential looks familiar to you. All right, and then we have our horizontal asymptote. Here it's just on the x-axis. All right, so there it is right there. All right, so there's our exponential. So now what we're going to do is graph the inverse of this exponential. So we have our xy table, and so to do the inverse, we just flip the ordered pairs. So -2, 1/4 becomes 1/4 -2. -1, 1/2 becomes a half -1. 0, 1 is 1, 0. 1, 2 is 2, 1. 2, 4 is 4, 2. All right, so now let's plot these new points. So 1/4 and -2. All right, so that's over here. 1/2 -1. 1, 0. 2, 1. 4, 2. All right, so this is the shape of this inverse graph. So this inverse graph is called a log graph. And this is what the shape of a log graph is. It's going to point down, typically, and it has a horizontal asymptote, and it starts on the y-axis. Okay, so the black one is going to be our new graphs when we start graphing. They're going to look similar to that. All right, so a log graph, or a log, and an exponential function are inverses of each other. All right, so when we're solving exponential equations, we're going to be using logs sometimes, and then when we're solving log equations, we're going to be using exponential sometimes, and that's how we're going to solve them. It's similar to when we were solving a square root function. To get rid of a square root, we had to square both sides to get rid of the square root, and that's because squares and square roots are inverses. If we were solving a problem that had x squared in it, we would have to square root both sides, because that will get rid of a square. And then similar to cube roots and cubes. All right, so if we want to change forms, that's going to be the basics of logarithms and exponentials, is to change forms from one form to the other. It's similar to a mixed fraction and an improper fraction. All right, so 2.5 and 5/2, they're equal to each other, they just look different. All right, and so that's what we're working with here with exponentials and logs. They're going to look different, but they actually are the same thing. So if we want to change forms, you can see an exponential form b to the x equals y. B is called the base. All right, and so we want to keep the base with the exponent. And then in log form, we can see the word log, and then the b down here in the subscript position, this is called the base of the log. All right, and then you can see where the x and the y's go. So when we want to change from one form to the other, you want to think of this down cross cross. I think it helps a lot. All right, so let's go ahead and practice changing forms from one form to the other. So we're going to change from exponential form into log form. All right, so since we need to write this as a log, we're going to write the word log. All right, now 3 is our base. All right, so you want to find the base because it's the one that's carrying the exponent. And this is where the down comes in. So that base comes down, comes down to 3, into the base. And then you want to think cross, cross. So the 9 is going to come on the left side of the equal sign, and the 2, which is up in the exponent, goes on the right side of the equal sign. So this is read as log base 3, 9 equals 2, or log 9 with base 3 equals 2. So the exponent is what the log is equal to. All right, so the exponent's 2, and that's what log base 3, 9 is. It's equal to 2. All right, let's try x to the 5th equals 7. All right, so we write the word log. We bring down the base, which is x, and then we switch the 5 and the 7, or cross them across the equal sign. So 7 equals 5. All right, number 4, 10 to the 3rd equals 1,000. So log, our base is 10, and then 1,000 equals 3. All right, so the log base 10 of 1,000 is really just equal to 3. All right, now 5 is written a little different. 16 equals 4 to the x. So in this case, you may want to flip this around so it's 4 to the x equals 16. So the exponent is on the left side. All right, so log base 4, and then 16 equals x. All right, so now we're going to do the reverse. We're going to change from log form into exponential. All right, again, think of down, cross, cross. So we want to find the base of the log first, just like we found the base of the exponent. So the 4 gets written first, and then we're going to switch the 16 and the 2 across the equal sign. So the 2 comes up as an exponent, and then equals 16. And 4 squared equals 16. That is a true statement. 4 squared equals 16. All right, 7. 2 is our base, so we're going to write 2, and we're going to switch the 1/8 and the -3. So the -3 comes on the left side as an exponent, equals 1/8. And 2 to the -3 does equal 1/8. All right, 8. X is our base, so x. The 2 goes up as an exponent, equals 36. And then 9. 10 is our base. Again, if you want to rewrite this so the log is on the left side, some people like to do it in one way every time, so just put the log on the left side. All right, so again, you can see the base is 10 to the 2nd power equals 100. All right, evaluating logs. So what we can do is, to start this off so you can see what we're doing, we can write this in exponential form. All right, and so what we can do is take the log, set it equal to some variable, we'll call it x, and then we can change it from log form into exponential, and then we could solve for x. All right, so if we change this from log to exponential, the base is 2, x becomes the exponent, equals 32. So now we just have to kind of look at our exponent sheet. 2 to what power is equal to 32? All right, and hopefully you look at your exponent, we know that 2 to the 5th power is equal to 32. And so that means that x has to equal 5. All right, and so the log base 232 is equal to 5. So when you do this, you can set it equal to x, change it to exponential, and then try to find the exponent. But what you can do with most of these steps right here is you're doing it in your head. So you're asking yourself, looking at the base, you're asking yourself 2 to what power is equal to 32? And whatever that exponent is the answer. Okay, so again, all this stuff, 2 to the x equals 32 and 2 to the 5th equals 32, all that writing down, you can do all that in your head if you can think of how the exponents work. All right, because we're trying to find the exponent. All right, so number 11, log base 9, 1. All right, so you're trying to think of, again, if you set this to x, so you can see it, 9 to the x equals 1. 9 to what power is equal to 1? All right, so 9 to what power equals 1? It's 9 to the 0, because anything to the 0 power is 1. So log base 9, 1 is equal to 0. Number 12, log base 4, 16. All right, so again, 4 to what power is equal to 16? 4 to the 2nd power equals 16. So log base 4, 16 is equal to 2. Again, if you were to change it into exponential form, you could see that 4 to the 2nd power equals 16. That's a true statement. All right, 13. Log base 4, 1/16. All right, so when you have a fraction in this position right here, you're thinking of 4 to what power is the 16. All right, so again, if you set this equal to x and change it to exponential, 4 to the x equals 1 over 16. All right, and then that 1/16 is a base, so you could flip it and make it a negative exponent. All right, and then you could change 16 to 4 squared. All right, and since the bases are the same, you can see that x is going to equal -2. 2 times -1 is -2. All right, so instead of having to do all this work, what you're really doing is asking yourself, 4 to what power is 16? That's 2, but because of the fraction, you have to introduce a negative value, so it's going to be -2. Okay, again, you can do all this work, that's fine, but you'll get the same answer. All right, number 14, log base 216, 6. All right, and so again, we're trying to find 216 to what power is 6. All right, so this one's a little trickier. So here, if we set this equal to x, change it to exponential, so 216 to the x equals 6. All right, and we could get the bases the same here. 216, looking at our exponent sheet from the previous lesson. All right, so 6 to the 3rd power is 216. 6 to the 3rd equals 6. And there's an exponent up here. There's a 1 there. All right, and so the bases cancel out. 3 times x is 3x equals 1. Divide by 3. So x equals 1/3. All right, so the exponent of 216 would be 1/3 to get 6. So 216 to the 1/3 power does equal 6. And you can check that on the calculator. All right, if you put 1/3 right there, put it in your calculator, 216 to the 1/3 power, it will come out to be 6. All right, number 15, log base 3, 1/9. So this is similar to number 13, where we have that fraction. So again, you're asking yourself, 3 to what power gives you 9? 3 to the 2nd power is 9, but because of the fraction, it's going to have to be negative, and so it's going to be a -2. All right, so 3 to the -2 power equals 1/9. All right, 16, log base 864. All right, so this one should be pretty easy. 8 to what power is 64? 8 to the 2nd power is 64. All right, 17, log base a half 8. So we're trying to find a half to what power is 8. All right, again, we have a fraction here. So think of 2, look at the 2, and so you're asking yourself, 2 to what power is 8? 2 to the 3rd is 8. But because of the fraction, it's going to have to be -3. Again, if we were to set this equal to x and change it to exponential form, we could get the bases the same. 1/2 is 2 to the -1. 8 is 2 to the 3rd. Bases cancel. -x equals 3. Divide by -1, x equals -3. So again, the exponent would have to be -3. So 1/2 to the -3 power does equal 8. All right, 18, log base 5, 25. So 5 to what power is 25? All right, so 5 to the 2nd power. That's pretty easy. All right, 19, log base 327. So 3 to what power is 27? 3 to the 3rd power is 27. Number 20, log base 20. So again, you're trying to think of 2 to what power would be 0. All right, so if we change it to exponential, just so you can see it. All right, so we know that if I put 0 in here, that's 1. 2 to the 0 is 1. 2 to the 1st, no, because 2 to the 1st is 2. So what happens is this number right here is never allowed to be 0 because there's never going to be a number that we can find as an exponent to raise a base to get 0. All right, so this is undefined. All right, so you can't take log of any base of 0. All right, and then 21 log base 2 negative 4. All right, again, you would try to find out 2 to what power would get you negative 4. 2 to what power equals negative 4. And if you try to throw some numbers in there, positives or negatives, even if you put in a negative 2, remember a negative 2 would result in 1/4, not negative 4. And so this number right here is not allowed to be negative either. And so this is undefined because you're never going to find an exponent. Okay, that satisfies that. So when you have evaluating a log, the number has to be positive. All right, and so it can't be 0, it can't be negative. It can be a fraction, just can't be 0, it can't be negative or 0. All right, so graphing. So we're going to kind of do the same thing that we did with all the other graphing. We have a parent function, make an XY table, and then we can do our transformations. With log functions, like we saw at the very beginning, we have vertical asymptotes instead of horizontal asymptotes. All right. So our parent function is always going to be y equals log base b x. All right. So that's the only thing, that's where how we're going to start it. So all the other numbers that are in the problem deal with transformations. Log base bx is the parent function. So in this problem 22, log base 4x is the parent function. Okay, so y equals log base 4x. Now what we're going to do is we're not going to actually graph this as a log function. We're going to graph it as an exponential because exponentials are easier to graph. So what we're going to do is change this to exponential form. Right? So y equals log base 4x in exponential form. Again, if you write the base 4, switch it around, log base 4x equals y. If you change this into exponential form, it would be 4, bring down the base, and then switch the x and y around. All right, so it's 4 to the y equals x. All right, so that's x equals, that's the same as x equals 4 to the y power. All right, so this form is the exponential form of this form, log form. So when we create our xy table, what we're going to do is we're going to use negative 1, 0, 1, but we're going to put them on the y side this time. And the reason why is because in exponential form, the exponent is the variable y. And so now we put those numbers in for y here, and we can find the x values. So 4 to the negative 1 is 1/4. 4 to the 0 is 1, and 4 to the first is 4. All right, and we don't have any transformations, so we'll just plot these 3 points. So 1/4 negative 1, 1, 0, 4, 1. All right, and so this has a vertical asymptote, and it always is going to start on the y-axis. Okay, and then we're going to go straight down and off to the right. So the vertical asymptote is based off the h value this time, not the k value, like in exponentials. All right, so our vertical asymptote is going to be x equals 0. That's the y-axis. The domain, if you go left to right, it's not negative infinity to positive infinity like in exponentials. This is going to start at 0 and go to positive infinity, and we're going to use a parentheses. The range is, if we go bottom to top, it's going to go from negative infinity and go all the way up to positive infinity. So the domain in exponentials, which is negative infinity to positive infinity, switches to the range. And so the range for log functions are always going to be negative infinity to positive infinity. All right, 23. All right, so our parent function is going to be y equals log, the base is 3x. All right, so that's how we start it. Y equals log base 3x, but we're not going to actually graph this as a log. We're going to graph it as an exponential. All right, and so the exponential form is going to be 3 to the y power equals x, okay, or x equals 3 to the y power. All right, doing our xy table. we're going to put negative 1, 0, 1 on the y side because the exponent is y. Plug those in to get x. So 3 to the negative 1 power is 1/3. 3 to the 0 is 1. 3 to the first is 3. All right, now we can apply the transformations that are occurring. All right, so that x plus 2 is a binomial, and so that's going to affect the x's, and it does the opposite. So we're going to subtract 2 from all the x's. And then the minus 4 is on the outside, and so that affects the y. So we'll subtract 4 from all the y's. All right, so again, you can use your calculators to get these, or use decimals. So 1/3 minus 2, that's going to be negative 1 2/3, or negative 1.6. 1 minus 2 is negative 1. 3 minus 2 is 1. And then finding the y's, negative 1 minus 4 is negative 5. 0 minus 4 is negative 4. 1 minus 4 is negative 3. All right, so let's plot these points. So we're going negative 1 2/3 to the left, and then down 5. Put us right about there. Negative 1, negative 4. So left 1, and then down 4. And then 1, negative 3. So right 1, down 3. All right, and then our vertical asymptote, we want to put that in before we connect these. And it's based off the h value. And so we have to take the opposite sign. So it's going to be x equals negative 2. And then let's go ahead and put that in there. X equals negative 2, so that's a vertical line at negative 2. And then we can connect these points, so it's going to go down and it's going off to the right. All right. Transformations, this is going left 2, down 4. Domain, as we go left to right, nothing hits until we go to negative 2, positive infinity. All right, so you can see the vertical asymptote answer is going to be in the domain. All right, and then the range, negative infinity to positive infinity. All right, so again, this number inside deals with your vertical asymptote. You just have to take the opposite sign. All right, 24, our parent function, y equals log base 5x. But we're going to change it to exponential form. So it's going to be 5 to the y equals x, or x equals 5 to the y power. You can write it 5 to the y equals x, that's fine also. All right, again, we're going to use negative 1, 0, 1. Put it on the y side. We're going to plug them in to get x. 5 to the negative 1 is 1/5. 5 to the 0 is 1. 5 to the first is 5. All right, now we'll apply the transformations. Inside the parentheses, x minus 4 affects x. It's going to do the opposite, so add 4. Outside affects the y's, so negative 3 is being multiplied on the outside, so we're going to multiply each y value by negative 3. All right, so 1/4 plus 4 is 4 1/5. Again, you can use decimals. 4 plus 1 is 5. 5 plus 4 is 9. On the y's, negative 3 times negative 1 is 3. 3 times 0, negative 3 times 0 is 0. Negative 3 times 1 is negative 3. Let's plot those points. So we're going right 4 1/5, and then up 3. 5, 0, so we're going right 5. And then 9, negative 3. So 9, right 9, down 3. Okay, we have a vertical asymptote. Okay, again, it's based off the number inside next to the x. So vertical asymptote is x equals 4. So let's put that in there, x equals 4. And so this graph, because of the x-axis reflection, that negative in front of the 3, it's going to flip and go up. instead of going down. All right, so our transformations, we have an x-axis reflection. Let's see, I'll go right 4, x-axis reflection, and then vertical stretch by 3. The domain, as you go left to right, it's going to first hit it past 4. All right, so we'll go 4 to infinity. And then the range, again, it's always negative infinity to positive infinity. All right, so our last one, our parent function, y equals log base half x. All right, so then changing this to exponential form, this is 1/2 to the y equals x, or x equals 1/2 to the y power. All right, doing our xy table, again, just use -101, plug them in for y. So 1/2 to the -1 is going to be 2. 1/2 to the 0 is 1, and 1/2 to the first is 1/2. All right, applying our transformations. X plus 2 affects x, so we're going to subtract 2 because you got to do the opposite. The y's, we're going to add 3. All right, so let's find our values. 2 minus 2 is 0. 1 minus 2 is -1. 1/2 minus 2 is -1.5. On the y's, -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. All right, so let's plot these points. So 0, 2 means we're just going to go up 2. -1, 3 is left 1, up 3. And -1/2, 4, left -1/2, and then up +4. Our vertical asymptote is at x equals -2. It's -2, it's right here. All right, and so this graph is going to look similar to the one just above it. It's going up instead of down, and that's because the base number is a fraction, less than 1. All right, transformations, left 2, up 3. Domain, going left to right, -2 to infinity. Range, -infinity to +infinity. All right, and that is it.